So let's go over activity 9 together. The general idea of solving exponential functions we've discussed first of all to convert back and forth between exponential structure and logarithmic structure. The second idea is to change your exponential structure into the same base, or similarly change your log expression to be of the same base, and because they are one-to-one function, so you can know the input must be the same. The last idea is to use substitution method, so you have some complicated structure and you can rename it as A, or whatever variable you like to use to denote as a new variable and make the calculation easy. So let's go ahead and get started. The first problem here, both of them share base E, so even though there are other ideas to solve it, one intuitive idea is to convert them to share the same base, therefore it's e to the negative x. For those two structures with the same base, their exponent must be identical to each other. Therefore, you end up with 3 being negative x. In other words, x is negative 3. The next problem here, 3 and 27. I hope you realize 3, 9, 27, 1/3, 1/9. Those are also something that can be phrased easily in terms of base 3. Therefore, this problem, 3 to the x and 3 cubed, which by the way is 27x squared, they are the same thing, is 3 to the 3x squared. So again, the two problems, they were changing to share the same base. So x must be the same as 3x squared. It's a quadratic function. The intuitive way of solving it is to factor it. I do not encourage to cancel out x from both sides because you have no idea whether x is 0 or not. So your final answer is either x is 0 or x is 1/3, because those two factors can be set to be 0. Therefore, x is 1/3 and x is 0. So the next problem, similar idea. I'm going to have a log structure, both of which share the same base. So it's just one step. So x must be the same as x squared minus 2. Like I said, for quadratic function, it's a good idea to move all terms to one side and factor it, or you use quadratic function. So once you got this, you end up with x being 2 or x being negative 1. Please pay close attention to the fact that you're playing with logarithmic function here. Whatever you put into log structure must be positive. It makes no sense to plug negative 1 into this function and try to calculate what's that. It doesn't exist. Therefore, your final answer, you can't use this. Your final answer is simply x plus 2. You have one single answer in this problem. Okay, so the next one we have is a single log structure. If you have a single log structure, you can convert back and forth between exponential and logarithmic structure. So 9 is square root of x squared plus 17. Therefore, you can square both sides to cancel out the square root. So you have 81 is x squared plus 17. Essentially, what you did is to try to square both sides. So square root and square is going to cancel out. Then you end up with 81 minus 17 is x squared. So you have x squared is 64. I encourage you to factor it to avoid the idea of missing any solution. So what you end up with is x being positive 8 or x being negative 8. It's quite obvious, both of which can be plugged into your log structure because it's going to be square, so you will never deal with negative values. So it should be good. This is my final answer. The next two problems, you can see that I have some power structure, but they were doing multiplication or subtraction, so I can't really merge them together. So I'm going to use substitution method. I'm going to have 2 to the x as my new variable. The first problem is 2 to the x squared, or if you want, 2 squared x. Both of which are correct. However, only by changing it to this structure, those two are related. So I'm going with this one. So I end up with 2 to the x squared minus 12. 2 to the x plus 35 is 0. Therefore, by calling a to be 2 to the x, a squared minus 12a plus 35 is 0. In other words, a minus 5 and a minus 7 equals 0. So a is 5 or a is 7, but you know a is 2 to the x, so 2 to the x is 5, or 2 to the x is 7, therefore x is log 2 of 5, or x is log 2 of 7, both of which can be evaluated and must be the answer to my previous problem. It's crucial for you to tell me what exactly is your assumed structure here. It's not okay to simply forget about this piece and tell me what's directly write down the new formulation without telling me what you meant by A, okay? So it's crucial to define it first. The next problem we have here is actually slightly more challenging, both of which you can see log 10 of 2x, but one have a exponent outside, one has exponent inside, so they are not technically the same thing. One thing we've learned is that you can throw the square outside, so you have 2 times log 10 of 2x. So there are different ways you can handle this problem. One way we could have done is trying to rename this piece where you see repeatedly in the structure here to call A. Therefore, your problem is A squared equals 2A. And for quadratic structure, I always encourage you to factor instead of do cancellation because it's very likely you're going to miss a solution. So I end up with A being 0 or A being 2. And you see what I'm saying? If you divide A from both sides, you end up with A being 2. It's highly likely you will forget the possibility of A being 0 because you were doing cancellation. You made the assumption A is not 0 right away. Okay, so I think it's always a good idea to factor to make sure you don't miss any extra solutions you may have here. And once we got here, I realized it means log 10 of 2x is either 0 or log 10 of 2x is 2. So in other words, 2x is 10 to the 0 or 2x is 10 squared. So 2x is 1 or 2x is 100. So x is either 1/2 or 50. I can take a quick look, both of which can be plugged back into my original function and this equation still holds. So I know that this is supposed to be my final answer and I have 2 answers here.